2.5. Postulates and proofs. In geometry, we have things called postulates. They are unproven theorems which we accept to be true. Through any 2 points, there exists exactly one line. If we draw 2 dots, we can connect them with a line. Through any 3 points, not on the same line, there is exactly one plane. This is what I've referred to in class as the wobbly chair. The 3-legged chair never seems to wobble. They always lie in a plane. A line contains at least 2 points. This one's very similar to the first postulate, which says any 2 points there is one line. A plane contains at least 3 non-collinear points. It's very similar to through any 3 points, not on the same line, there's exactly one plane. You'll notice some converses in these examples. If 2 points lie in a plane, then the entire line containing those points lies in that plane. If 2 lines intersect, then their intersection is exactly 1 point. And lastly, if 2 planes intersect, then their intersection is a line. Always a line, never a point. Here's the theorem. We haven't talked much about theorems before, but theorems are proven to be true in all circumstances. We have a theorem, the midpoint theorem. If M is the midpoint of line segment AB, then line segment AM is congruent to line segment MB. Here's our picture, and what it says is line segment AM is going to be congruent to line segment MB. Always true if we know M is a midpoint. Proof. We'll be doing proofs throughout geometry, so it is good to get used to how to write them and the format that you should write them in. There are a few parts of a good, well-written proof. First off, we need to state what is to be proved, the theorem or the conjecture. Next, we list the given information. This is the hypothesis, or the if part of a statement. Next, draw a picture. Pictures are always helpful, just like they are in word problems. Next, state what is to be proved, the then part, or the conclusion of our conditional statements. Next, and finally, write the proof. So let's see what a proof would look like for a paragraph proof. We're going to learn about paragraph proofs, algebraic proofs, and 2 columns. First off here it says state what is to be proved. We're proving the midpoint theorem. So we write the midpoint theorem. If M is a midpoint, then line segment AB of line segment AB, then line segment AM is congruent to line segment MB. List the given information. Remember, the given information is the if part of our statement. Given, M is the midpoint of line segment AB. Next, draw yourself a picture. Here's our line segment AB with M being the midpoint. And we were given that M is midpoint, so it would be a good idea to mark that on our picture. The way to mark that is that this piece is congruent to this piece. AM is congruent to MB. We know that because it was given to us. Next, state what is to be proved, or the conclusion. For this problem, it's AM being congruent to MB. That's what we stated. Easy enough. Finally, write the proof. This one is short, it's sweet, it's easy. We're just introducing it, so it's going to look pretty simple. Make sure to write down good notes because mainly what we're working on here is the design and the layout of a proof. In a paragraph proof, we write it as a sentence. By the definition of a midpoint, AM is equal to the length of MB. The reason we can say that is by the definition of congruence, AM is congruent to MB. Because we know that what congruence means, we can say that the segments must be the same length. That's what we were trying to prove, so we have completed our proof. Next, is this statement always, sometimes, or never true? If a plane T contains line EF, and line EF contains point G, then plane T contains G. A lot of words and a lot of shapes going on there, but if you take them one by one, it's not too bad. First, we have a plane T, so think of the floor. Then, on that floor, there's a line EF. And on that line, there's a point G. All of that information was given to us, so all of it has to be true. Next, the conclusion we're going to draw is that plane T must also contain G. Well, there's absolutely no other way to draw it other than having the line and point G on the plane. The reason we know that is because of the theorem, or excuse me, the postulate. If 2 points lie in a plane, then the entire line containing those points lie in that plane. So this is an always true. So we always know that this is going to be true no matter what the situation is based on that information because we're using the postulate that tells us it is always true. Here's another example. For line XY, if X lies in plane Q and Y lies in plane R, then plane Q, must intersect plane R. What we're saying here is if you think of your room, wherever you are right now, if you put X on the wall and Y on the floor, you can connect those two because anywhere you put 2 dots, you can connect those. Any 2 points make a line. So no matter where you put those points, they're going to make a line. So if we put the first dot on the wall and the second dot on the floor, those 2 planes run into each other. Now, what if we decided to put the point on the ceiling and the other point on the floor? Now those points aren't going to run into each other. So this question is actually a sometimes. They don't always have to. We had an example where if they're on the wall and the floor, the planes hit each other. But if they're on the wall and the ceiling, or excuse me, the ceiling and the floor, they would not hit each other. Our final example is line GH contains 3 non-collinear points. This one hopefully should be somewhat simple if you've understood what non-collinear means. This is a never. Because the definition of non-collinear is not on the same line. So this one's saying line GH contains 3 points not on the same line. That doesn't make any sense, and it's definitely a never. That is the end of the notes for this section. I know the stuff with postulates and theorems should be a little bit new to you because we haven't talked about it, but that shouldn't be too challenging to learn about and to understand because they're very similar to definitions. However, the information about proofs I know can be challenging. Don't give up, make sure to ask lots of questions, and I'll help you out when you get stuck.